Hello students, I will turn your attention to assignment 4 notes, which contains a lot of helpful data. The first thing I'd like to do is to go over the new data structure that we're going to be doing in assignment 4 and in assignment 5. This is different from the vector ADT that we were using for the previous assignments. The data structure we are going to be building is called a linked list. Linked list is a sequential and dynamic data structure. However, you may say, oh, our dynamic array was sequential. It was also used dynamic memory. So what is the difference? Well, let's get a pictorial representation. So here is our vector ADT. And here is our, so which had contiguous memory locations. We gave an initial size. And of course, we had the option, if we ran out of memory, we could extend the size and get ourselves double the memory. But we had to make a commitment, some kind of commitment for size. The linked list looks something like this. Start off with one object. And then if you need another, request one from at that time, dynamically ask the computer to give you from the heap another object. And that could be anywhere. Let's say this is here. However, because it's not stored in the next contiguous location, we had no prior commitments made. We did not do any prior allocation. We did not get ourselves a block of memory. Well, now we have to take what we got. But the way that we can find our way to the next one is to create a pointer to the current memory location. And we can keep building by making these requests and then creating pointers to daisy chain or link them all together. Of course, we keep a front pointer that points to the front of the chain. Otherwise, we would not know where to get started. And then we follow the links to reach our destination. And this is the way we can grow our linked list. And this is the way we can start from the beginning and search through the linked list. So let's start inspecting the contents of these objects. These objects are called list nodes. And this is what we are going to be covering in this assignment 4. List node contains two parts. The first part is the data, and the second part is the next. The data in our case currently is integer, but it can be of any type T, including songs, which is what we will be doing in assignment 5. The next contains the address, the memory address of the location of the next list node. So for example, this is if this next list node was in 102.10110, then 10110 is what is going to be stored here. So these are the two parts, and we are going to create a class which is called ListNode class, which has got two elements. One is the data and the other is the next pointer to another list node. So in that sense, to think about it, it's a kind of a recursive definition. It's a precursor to some of the recursive operations and concepts that we will be using later on in the course. Now, just to compare some of the operations between list node, between the vector data type and the list node, well, if you're going to search for an element, then we are going to be starting from the beginning here. We know this is the index 0, and then we are going to be inspecting it sequentially. We do the exact same thing here, start from the front and then examine the link. Let me put some integers here, 5, 7, and 9. And we can start from 5. If you're looking for the number 9, we start here, follow links all the way till we reach 9. Now, if there is no subsequent list node, then I'm just going to use a slanting line to indicate this is the null pointer. So initially, of course, our front will be set to null pointer, and as our list grows, then it's going to start to point to the first element. Now, how do we add elements? Well, that's easy. We follow to the end. Add is going to follow to the end and add at the back. That's what we've been doing. But as you can see, this is not such an efficient operation. We can also make our linked list grow from this side. So we're just, adding elements here. We're not following all the way up to the end. The position we will take for assignment 4 is that add is going to start from the front, go all the way to the end, and add at the back. Right? Now, what about adding to a linked list? We do exactly the same thing. We just go to the next position, next available position, and add an element here. Right? Now, let's look at insert. Now, the big difference is that for a linked list, for a vector data type, for a vector, when we were populating the vector, we stored elements into the vector, and then we sorted the vector, right? Because we needed to keep the elements sorted in order to make our search faster. Whereas in a linked list, as you can see, the pointer feature makes it easy for us to create a linked list in a sorted order. How can we do that? Now, the cautionary note that I will say here is links have to be managed with care in a linked list. And if we get comfortable doing that, then we will see that these operations sometimes can be much more efficient than other data structures. So the question is, if I was building my database and I wanted to add the number 8, then if this were the vector data type, I would add it first and then I'd have to sort the entire database. But with this one, what I do is I start searching. I start with 5, go to 7, find that 8 is between 7 and 9, so I have to insert it somewhere in the middle. And I go get myself a ListNode, put the data here, but I'm going to do a kind of a tricky operation in that the next pointer of 7, I'm going to make it point to 8 because this one now needs to get inserted after 7. And then the next pointer of 8, I'm going to set it to 9. So now I'm going to start with 5, go to 7, go to 8 and 9. However, I have to let go of this link here. I have to make sure that this link gets deleted so that the chain is set up properly. So this is how I can insert an element. Similarly, now that kind of insertion is not possible. I mean, that's what we've been doing in a vector, but it needed a lot of right shifts. And removals needed a lot of left shifts. As you can see here, we don't need to shift because we can insert in place. Now, how to remove? Let's say if you wanted to remove the number, 7, let me get rid of this one first. If I wanted to get rid of the number 7, then what I would do is I would find out who's after 7. And I know that the node after 7 is 8. So I know I have to skip 7, and I can do that very easily by setting the next of 5 to the next of 7. But at the same time, this link is going to get broken. And I'm going to delete that. And I also have to make sure that this element gets released and deallocated so that the garbage collection can happen. This can get recycled with all of the links now not pointing to anything, but our 5 can point straight to 8, indicating that the path to 7 is broken and therefore 7 has been deleted. So as you can see, the insertions and deletions do not need the scooting up and down, and that makes this a very powerful database. Now I'd like to go over the notes here. And so what do you need to do? You need to construct the ListNode class using fields data and next pointer. The constructors need to be set up. Getters and setters need to be written. This is for the ListNode class. Now what are we going to do in the driver? In the driver, we are actually going to daisy chain, create list nodes and daisy chain them together and test out our insert, delete, add, and search functions to make sure that we are setting up our links or deleting our links properly. So here are the 4 methods, the add, insert, remove, and search that you will be implementing in the driver. In assignment 5, these methods will be incorporated into a linked list class, right? And then they will be moved out of the driver. And for now, we are only going to be staying with integers, not songs. and we're going to be doing these functions in the driver. So let me go into the template, and so this is the template for assignment 4. And as you can see, there is a ListNode class which is given to you. The header file is given to you. The ListNode CPP is given to you, and wherever it says given, the constructors are given to you. There's one constructor that you need to write where you set the next pointer to the incoming next pointer, and the toString method is given, the getters are given, and you're expected to write the setters for the data and for the next. With regard to the main program, then the REM documentation has been given in detail to help you write those and implement those methods. Some of these, the main program has been given to you, and it involves creating the front pointer to start the daisy chain, adding nodes, inserting nodes in the middle, deleting nodes, emptying out the list altogether, restarting or reestablishing the linked list. So basically testing our insert, search, and remove methods, so you can keep them the main program as it is without any changes. What about the methods? Some of the methods, print list, search, have been given to you, add node have been given to you. And if you inspect this, you will see you will get a lot of code that you can reuse in your insert and remove methods. Because, for example, the front point current, you create a current pointer that and equate it to front, so you're not changing the front pointer, because so that you can traverse the linked list and still keep the front authenticity of the front pointer, maintain the integrity of the front pointer. So the two methods that need to be written are remove and insert. And the output has been given to you. We are creating a list of integers. So when your methods are all in place and you run your program, then your output should be as expected.